everybody. My name is Pablo Torres. I am a chief of the dialysis service at the Aura Saint-Ouen, Paris, in France. And this is a pleasure and a great honor to moderate this e-seminar or webinar, which is entitled 2022 Update on Biomarkers of CKD-MBD, organized by the CKD-MBD Working Group of the European Renal Association. In this update will be presented by my friend, Dr. Etienne Cavalier. Etienne Cavalier obtained his diploma in pharmaceutical science in 1994 at the Liège University, Belgium. He then specialized with the highest distinction in the clinical biology of the same university in 1999. And he did his PhD in biochemical and pharmaceutical science in 2010 in Liège University, and he is since working as a professor of clinical chemistry in the same university. He's one of the worldwide experts in PTH, parathyroid hormone measurement, as well in the assessment of other mineral and bone circulating biomarkers, particularly in the situation of CKD-MBD. I am sure he will talk a lot about PTH and its fragments, but also about fibroblast growth factor 23, bone-specific alkaline phosphatases, and tartrate-resistant acidophosphatase or 5B or TRAP5B. And we hope that this update will provide you with the information to improve your clinical capacity to interpret the clinical value of these biomarkers in the setting of CKD-MBD. Etienne will be challenged not only by me, but by two co-chairs or panelists. The first one will be Dr. Hanne Skou Jorgensen from the Department of Clinical Medicine at the Aarhus University in Denmark. And the other one is Professor Marc Vervloet, Associate Professor at the Amsterdam University Medical Center from Netherlands. I would like also to remember you that by participating in live to this e-seminar, you will earn 1 CME credit. And this event, as all the working group e-seminar are accessible free of charge for all the ERA members. The only thing you have to do is to register on the web page in your My ERA digital area, and also by clicking in the My CME courses. After the presentation, we have around 30 minutes of Q&A section with the panelists and myself and the participants. And you can also submit your question by clicking and dropping them in the chat. At the end will be a questionnaire to obtain your diploma. And without further doing, I wish you a fruitful and interactive e-seminar. Please, Etienne, this is your turn.
Thank you very much, Pablo. Very much for your kind introduction, Pablo. And it's a really great pleasure for me to talk about one of my favorite topics, which is biomarkers of CKD-MBD for the ERA-EDTA CKD-MBD working group, which I'm very proud to be part of. So here are first my conflicts of interest and the agenda for today. So today it will be the clinical part, the clinical side of those bone markers, and we'll go definitely analytics. I will try to drive you into the labyrinths to try to better understand the different assays, and we'll be talking particularly today on parathyroid hormone, as you mentioned, Pablo. That was my PhD thesis in 2010 already. So I will present you very new data and still unpublished data. So I'm very proud of presenting you this data today. And then we'll make a switch to two bone markers. The first one, which is bone alkaline phosphatase, which is a very well-known markers in the field of CKD-MBD, because it's recommended to use it in the KD organized. And I would like also to present a couple of slides on TRAP5B, which is a bone resorption marker, which could, at least in my sense, could be really interesting in the field of CKD-MBD and also in the follow-up of bone resorption in any patient suffering from chronic kidney disease, because as you know, CTX cannot be used, and this could be really an added value. So this is a bit, the title of today was the 2022 update, so it's a bit a selfish thing. So I decided more or less personally to present you these talks. I could have talked about different things, but I would like really to focus on what was really new and what was really, at least for me, quite new compared to what we had in the past. So we'll start first to talk with of parathormone. And well, a bit of publicity if you are interested in the NDT. The digest that I wrote was, what does a PTH of 300 picogram per ml actually mean? This is something that I've been invited to write because often when I'm attending different nephrological congress, I often hear you all guys talking about this patient that's got this PTH at whatsoever level, and at the end of the day, what does that really mean? I would like to present this paper from the Mayo Clinic and the CDC. And this paper was really interesting because the authors aimed at really to characterize and to quantify the different PTH fragments as well as 1 to 84 PTH. And they use high resolution mass spectrometry, which is a bit different than what maybe you hear the famous tandem mass spec, LCMS-MS. This is another instrument that really helps to identify different fragments. And what they did in this paper, so they took any antibodies that they could find, and they incubate the serum or pool of hemodialyzed and CKD patients with all those antibodies. And at the end of the day, they really quantify what those antibodies had captured. So here I'm talking about antibodies targeted against the C-terminal part of the peptide and antibodies targeted against the amino terminal part of the peptide. So their aim was really to identify all the fragments that could that do circulate in the serum of CKD patient. And this is one of the major slides of this presentation, where you can see so that they identify something like 8 different fragments. So you see that some of them are truncated in the C-terminal part. Most of them are truncated again in the amino terminal part. Some of them have kept the C-terminal part, and you can see here the concentration of those fragments, which can be quite important, like for instance, the 3877 here, which is at more than 800 picogram ml. But what we can also see here is the 1 to 84 PTH, and it does seem a rather small peak, if you can say peak, but a small bulge here. And this PTH is at 200 picogram. So this is really 200 picogram in a CKD or hemodialyzed patient. So really interesting, because for the first time, these authors really show the ID cards of the different circulating fragments observed in the serum of CKD patients. The limit of quantification was a bit high, which was something like 35 picogram ml, but still all those fragments are present in a high concentration. Other slide that they present in their paper was also really interesting. Here in dark gray, you see the PTH 1 to 84, which has been measured with the HRMS. And here on the light gray is the intact PTH as measured, or second generation PTH as measured by the Cobas, Roche Cobas instrument. And what they see is that they see an increase of the PTH when it is measured by the intact assay, so second generation, compared to the tandem mass spec. And this increase is different, right? There is a difference in CKD4, and that you only see that PTH 1 to 84 start really to increase in the CKD stage 5 of those patients. And of course, see if it's obvious, but with intact PTH, second generation PTH being much higher in those patients compared to the PTH 1 to 84 as measured by the HRMS method. But what the authors did also is that they synthesized all those fragments, and they played with those, right? They played with those fragments. They spiked those fragments at different concentration in a neat serum, in a normal serum. And what you can see is that there was no cross-reactivity with any of these fragments with the Roche-Cobas assay. So it's quite strange and intriguing that when you look at this, you can see that the fragments are the reason why there is a discrepancy between the 1 to 84 PTH as measured by the HRMS and the Cobas. But when you spiked all those fragments, you don't see any cross-reactivity. The only cross-reactivity that you can see is with the 7 to 84 fragments. But this fragment, as you can see here, has not been found in a native status in hemodialysis or CKD patient. And these authors had already published a few years ago that there was not presence of 7 to 84 fragments in the serum of the CKD and hemodialyzed patients. So really, this is purely an artificial cross-reactivity because this fragment does not exist. But still now, having no cross-reactivity, whereas you can see a difference with the when it's measured by the immunoassay, is quite intriguing. But in these other papers, the authors have come with a more basic science approach. So they wanted to see if those fragments had a biological action of a culture of osteoblast. And the answer is no. There is no. Alone, these fragments do not have any action on the culture of osteoblast. But when they incubated the osteoblast with those fragments, and then they gave a 1 to 84 PTH, with some fragments, they saw an increase of the amount of cyclic AMP generated in the culture osteoblast. So by this approach, they show that the fragments can potentiate the activity of 1 to 84 PTH on the culture of osteoblast. On the other hand, which is also a bit strange, is that some other fragments reduced the effect of 1 to 84 PTH in the osteoblast because it did decrease the production of bone alkaline phosphatase. So as a result of this study, the fragments seem to modulate, I would say, of course, this is not observed in humans, this is observed in culture cells, but seem to modulate the action of PTH, on one hand, increasing the cyclic AMP, but on the other hand, decreasing the bone alkaline phosphatase production. So, of course, this is a very early finding that needs, of course, to be reproduced, that also needs to be understand. We need to understand what does it mean really in humans, but at least I really find that these findings are really of interest. In our lab here in Liège, we have been also working on thermal mass spec determination. So this is thermal mass spec, LC-MS, and not high resolution mass spectrometry, but thermal mass spec is more sensitive so far than HRMS. And so we have been working to see if we could propose to go through what we could a reference method for the quantification of 1 to 84 PTH. So what we really want to do was to accurately quantify the 184 PTH, no oxidized, no whatsoever, but just the 1 to 84 PTH. So for this approach, we decided that we did not want to go through a triptych digestion. When you want to quantify peptides with thermal mass spec, if these peptides are too big, you need to use enzyme like trypsin that cuts the peptides in small parts, and then you have to measure these smaller parts. But here with PTH, there are already so many circulating fragments that I had the feeling that coming with another triptych digestion could create more confusion than real what happened in reality. I did neither want to use antibodies like they did in the Mayo. It was my decision because I wanted to have something that was totally independent from any immunological reaction. So we used more the physical chemical properties of PTH to quantify it with the thermal mass spec. We also wanted to have a limit of quantification, so the smaller concentration that you can measure with PTH, around 5 picogram ml, which is what is proposed by most of the immunoassays. So we wanted to go as low as possible. And of course, we wanted to calibrate this thermal mass spec with the WHO international standard 95646 to calibrate the method. So here are the results that we would like to present to you. So this result has been so far unpublished. So these are very preliminary. Of course, you are in the process of submission, but these are, I was very happy to share them with you. So here is what you obtain when you spike into a clean matrix 1 to 84 PTH. The oxidized PTH in 8, oxidized in 18, oxidized in 8 and 18, and the 7 to 84 fragments. So this slide is just to show you two things. The first, that I can really quite easily identify the different PTH forms, and then I can clearly separate them. And I would like you to pay attention to the time of retention of PTH, which is at 6.6 minutes. So after 6.6 minutes comes the peak of PTH. And I will show you this peak in the next slide. So this was a clean sample. What about the patients, of course, because we are working in patients. So this is a patient that presents a concentration of 5.8 picogram ml. And if you see here at 6.6 minutes, you've got the nice, already a very quite easily quantifiable peak of 1 to 84 PTH. Of course, you can see here the background, the noise. We are at very, very low concentration. And if you look here at the scale, we are at 6,000. We'll show you what will be the difference after. But still, that was the first goal, to be able to quantify quite easily a sample around 5 picogram per minute. Next, this is a sample, a human EDTA plasma sample presenting concentration at 32 picogram ml. So here you can see that the scale is different. It's 20,000, it's not 6,000 anymore. And here you can easily see at 6.6 minutes, the very nice peak of 1 to 84 PTH. And this 32 picogram per ml is the upper limit of normality of the assay. So 32 quite easily found, and with no cross, with no other peak interfering with our system. And this is finally a sample of a hemodialyzed patient at 234 picogram per ml, which is approximately 8 times the upper limit of normality. And you can see here that the scale is also changed. It's 160,000, and we've got this huge peak of 1 to 84 PTH that we can easily quantify in the serum of the patient. You can see the background here is very nice and very clean, so it's quite easy to quantify now PTH. See the retention time at 6.6, but so we can really identify the PTH, which is a very nice peak compared to the one that had been previously shown with the HRMs. So what did we do with our autonomous spec? We quantified PTH in 80 patient CKD hemodialyzed patients, and we measured all those 80 patients with all the different assays that we can measure in our lab. So second generation PTH, third generation PTH assays. So here we got, for instance, the Abbott second generation, ISIS second generation, Diasterin liaison second generation, Beckman Access, Siemens Center, and Roche Intact second generation. And here on the right side, you've got the third generation PTH, which, if you remember, are those kits that use an antibody targeted against the first amino acids of the peptides. And so the third generation PTH, so we can measure it for different methods. So it's the Diasterin liaison third generation PTH assays, bioMérieux Vidas, Roche Cobas third generation PTH, and Fuji Radio third generation PTH assays. So if I show you the different, this slide it's very exciting for me. And there are different things that we can learn from this. The first thing is that you can see the major problem with the different PTH assays is the lack of standardization. Of course, what you would expect is to have the slope exactly corresponding to this here, to this 45 degrees line. But as you can see that there is an overestimation of the true PTH concentration with the second generation PTH assays. When you look at the third generation PTH assays, it's not so important. Some of them, like here, the Fuji Radio, is more or less perfectly correlated with the mass, Somewhere else are a little bit, the slope is a bit different, but still it's also a matter of standardization. Thus, Fujirebio is the only one to be clearly claimed to be traceable to the WHO standard. But the second thing that you can learn from this slide is that you might have expected a huge scatter around the area of agreement, because we expect that in second generation PTH assays, the fragments cross-react and would have given a huge scatter around this. But obviously, this is not really the case. You do not see so much different scatters with these assays that are not supposed to cross-react with any fragments. So one of the findings that we can deduct from this study is that if you really re-standardize second generation and third generation PTH assays, all these kits could give you the same clinical information. And this is really something that is really important, and that needs, of course, this is really preliminary data that I'm sharing with you, but still this is something that we could deduct and think that just recalibration would really help the life of nephrologists. And this is something that had already been proposed by my friends Jean-Claude Souberbiel and Denis Fouque in 2012, if I remember correctly, where they said, okay, if you divide by different factors, you come to the same clinical conclusion. And this is basically what I can prove now with the ThermaSpec assay, and that really measured 1 to 84 PTH and none of the fragments. A thing that we've been also talking about is the oxidized PTH, and was oxidized PTH a new analytical challenge? So as I already mentioned, the PTH has 2 methionines here in position 8 and position 18, and these methionines are prone to oxidation. And there has been studies where the authors have oxidized PTH, completely oxidized PTH, and showed that there was no biological activity of the peptide anymore. And there is a possibility that to remove the oxidized PTH with a small column, with an antibody, and the same group actually has made different studies with this oxidized PTH, and they show that the non-oxidized PTH, but not the oxidized PTH, was associated with the evolved primary composite endpoint, which was mortality, by the way. So these authors have really proposed, and proposed that we should not measure total oxidized plus non-oxidized PTH, but we should only focus on the quantification on non-oxidized PTH, which is for them, and I agree, the only biologically active peptide. So was that a new analytical target? So since it was the only team that has been working on that, with Marc and Peter and other colleague here from Amsterdam and Leuven, we have shown that also by using the small cartridges that can capture the oxidized PTH, and when we measured PTH after capturing the oxidized PTH, we did not find any superiority of the non-oxidized PTH compared to the total PTH to assess the bone turnover in chronic kidney disease. So from a clinical perspective, our group did not find really any added value of measuring only the non-oxidized PTH alone. But what is even more problematic is that I'm referring again to this paper that has been published last year in Clinical Chemistry, where they use the high resolution dynamic spectrometry. The authors say that they were unable to find any oxidized form of PTH in the pool of the patients. So that really put some threat on this. So they were not able to say, well, we do not find any oxidized PTH in the serum of our CKD and hemodialyzed patients. And if you remember, I proposed to this here chromatographic peak showing the very nice 1 to 84 peak, but in this hemodialyzed patient. But here, if you remember one of the previous slides that I showed you, if there was oxidized PTH, and if there was 7 to 84 PTH in the serum of those patients, I should have seen peaks here, because this oxidized PTH is supposed to to be less than 10% of the total PTH activity, according to the paper that had been published in the past. So if this was to happen, I mean, I would have seen a big and huge oxidized PTH here and a very small 1 to 84 PTH, which is absolutely not the case. What we do really see with our mass spec approach is that we really see a 1 to 84 PTH and no oxidized forms, no 7 to 84 PTH. But then you might argue that it is because my sample preparation has an issue. Maybe that the oxidized PTH is lost somewhere in the way that I'm processing the samples, and I would only keep the non-oxidized PTH, and then the oxidized PTH vanished away. So that we make another approach to prove that there was an issue with this oxidized PTH approach. For that, we took a hemodialyzed serum of a hemodialyzed patient, that contained 383 picogram ml of non-oxidized PTH. And what we did is that we oxidized the international standard. So we put this standard 1 to 84 PTH in contact with a huge amount of hydrogen peroxide, and so we were able to completely oxidize the PTH, just like they did in the paper showing that oxidized PTH was biologically inactive. And so we added here this completely oxidized PTH to the serum of our patient. And we measured this patient, we passed this patient, the serum of the patient, on our mass spec. And what we can see, yes, we saw definitely, we had this big, huge peak of oxidized PTH, for sure. And we had also a second peak, which was here at 321 picogram. That was the peak that we of the non-oxidized PTH. So by spiking oxidized PTH in the serum of the patient, I can definitely see this oxidized PTH through my sample preparation, showing that my sample preparation does not exclude the oxidized PTH. I can definitely see this oxidized PTH. But what happens if I measure this serum with the COBAS assay, which was the one that is being used by the different teams talking about oxidized PTH? You can see that total value of PTH is 1,360 picogram per ml. So it's the addition of both. So it makes around 800. And if maybe if you saw, the COBAS is 1.3 to 1.5 higher than the mass spec, exactly explaining that the COBAS is quantifying both oxidized and non-oxidized PTH when oxidized PTH is present, but still there is no oxidized PTH present in the sample. So now what we wanted to do is to perform the same study with those small columns that possess the antibodies that binds the oxidized PTH. So we took our sample and we passed it on our column. So what should happen? All the oxidized PTH should be captured by the antibody. And then here in the remnant, you should only see the non-oxidized PTH, right? So if this antibody is specific for oxidized PTH, I should, when I pass this serum on the column, all this oxidized PTH is captured and the non-oxidized PTH goes in this tube. And so that's what we did. And so we measured this, what was obtained after this percolation of on this column. Result, of course, there was no oxidized PTH anymore, but still look, there was no 1 to 84 PTH anymore. This really shows that the antibodies present on this column are not specific for oxidized PTH, and they also capture the non-oxidized PTH. So here I had a flat chromatogram with, this is limit of quantification, remember it's 5 picograms, so even lower. So no oxidized, no non-oxidized PTH. But what happens if I measure this on the COBAS? I find the concentration of 63 picogram per ml, which is, I don't know, this is not PTH, this is not oxidized PTH. So is it matrix effects? That's possible because the matrix could have an impact. But here, if you see 63 is more or less what you would have obtained if you had measured a serum, passed a serum on this column. So as a conclusion, of course, of this preliminary conclusion of what's this finding of the experiment is that we're not able to find oxidized PTH in the serum of him on the plasma, sorry, of hemodialyzed patient, and that even when you spike the oxidized PTH and you pass it through the column, of course you are losing the oxidized, but also this antibody does not seem to be specific for the oxidized PTH and also capture the non-oxidized PTH, as we can demonstrate by the absence of a peak on our chromatogram. So that was what I really wanted to present to you with PTH today. And now, if you permit, so I will switch to another important marker that Pablo knows very well also, which is bone alkaline phosphatase. And from the lab perspective, how can we quantify bone alkaline phosphatase? Well, most of the labs are using automated methods to measure bone alkaline phosphatase, either, for instance, the diastereomere liaison XL, the IBS-ISIS, and the Beckman-Coulter access. So these are what we call ostases that provide you concentration of bone alkaline phosphatase in microgram per liter. Watch out that there is also this enzymatic immunoassay, which is in EIA from Quidel MicroView, which is not measuring the quantity of bone alkaline phosphatase in microgram per liter, but the activity of the enzyme in units per liter. And there is a magnitude of 2 in the concentration between units and concentration. For instance, a patient that presents a bone alkaline phosphatase measured by the MicroView at 40 units will present a bone alkaline phosphatase measured by the immunoassay around 20 microgram. So what shows is that sometimes there is a misunderstanding about the units, but this really has an impact because there is a magnitude of 2 between the activity and the mass of the enzyme. So again, what about the harmonization of bone alkaline phosphatase assay? And here I would only focus on the ostase, so those that measure the bone alkaline phosphatase in microgram per liter. So we published a few years ago this correlation graph between the different methods that are available, and you can see that the agreement is the harmonization is not wonderful. And I'm afraid also to say that it's changed a little bit over time. So harmonization of bone alkaline phosphatase assays needs to be improved, and this will be one of the tasks of the IFCC committee of bone harmonization or bone metabolism that I have the privilege to chair, to really try to improve the harmonization of those assays, even if it's not the worst, of course, compared to what you observe with PTH. But there is another way also to evaluate the bone alkaline phosphatase, and this is chromatography, and this is gel chromatography. You are probably used to this electrophoresis of total alkaline phosphatase, where here you can see that you can separate some of the different isoform of the alkaline phosphatase with the intestinal and the liver form. Here you can see, and the most, of course, as you know, the most important forms are the liver and the bone forms, which represent half of the activity of the total alkaline phosphatase. But this is a gel separation, and it's already a paper that now is more than 30. Well, it's 30 years old, not more. But this here, a great paper by Per Magnusson from Sweden, where they use HPLC, so a higher level of separation to separate the different isoform of alkaline phosphatase. And you can see here they've got the liver form 1, 2, 3. But he also said that there was not a single isoform of bone alkaline phosphatase, but there was 3: the IB, the B1, and the B2, which could not be here identified on the gels because this has a higher resolution. But what is even more interesting, I would say, is that this team here a few years later has been able to identify a fourth form, which they named B1X, that you can see here in serum of hemodialyzed women compared to the form that they saw in healthy women. So this separation is not very obvious to perform, and these are the only person that are able so far, to the best of my knowledge, to separate those forms. But this B1X is really interesting, and because they made different papers on this, so they show that it was present in not all the serum of hemodialyzed patients, around 60% of them. No correlation between bone alkaline phosphatase, total bone alkaline phosphatase, and this B1X. There was better correlation with PTH, And there was quite interesting feature because they showed that present patients were older and present lower median levels of BTM bone markers compared to those who did not present this. And they came also last year, 2021, with a very interesting paper where they also show that this novel bone alkaline phosphatase, even if it was found 30 years ago, B1X was associated with improved 5-year survival in hemodialyzed patients. So I do really believe that this B1X story is something that we definitely should investigate and maybe see if we can come with other approaches to have a good quantification, because here it's more the presence of absence of this B1X isoform. But I do really think that this is really interesting to have this form better characterized, and there is some work that is open that with the team of Matthias and Per. And finally, I would end with a couple of slides with TRAF5B. TRAF5B is a great bone resorption marker. It's not like CTX, which you know, of course, which is more collagen, but CTX accumulates in the serum of CKD patients because it's cleared by the kidney. CTX is influenced by the circadian rhythm. CTX is influenced by food, which is not the case of TRAF5B. TRAF5B is not influenced by CKD, not influenced by food, not influenced by circadian rhythm. And in Japan, for instance, it's the marker which is recommended even in osteoporotic patients for the monitoring of bone resorption. And bone resorption is something that could really be interesting. Of course, you know that better than I in the exploration of CKD patient, hemodialyzed patient, but also to osteoporotic patient presenting CKD. And there are two major methods to quantify TRAF5B. One is an automated method that is available in many different labs in the world with the IDS ISIS. And one is the one that is widely used in Japan, which is the Nitobo ELISA. And this Nitobo ELISA is used very widely in Japan. They're measuring millions of samples with this thing. And what we show with this paper that we published last year or earlier this year was the correlation between those two assays, the Nitobo Medical and IDS ISIS, in different cohorts of patients, CKD, hemodialyzed, osteoporotic, postmenopausal women, and patients suffering from rheumatoid arthritis. And what you can see here is the very nice agreement with TRAF5B, with those two TRAF5B assays, which is better than what you can see what I presented to you earlier. So the message of this is that I think that TRAF5B could be really an interesting tool survey in the exploration of CKD and hemodialyzed patients, that the assays, the tools that we have in our hands to measure the activity of this interesting resorption bone marker is really good, and then the results that we obtain with those assays can totally be reliable. So if I summarize to my long talk today, so what did I say? Well, I said that the recent findings that I present to you today raise some doubt on the interference of the pH fragments on the immunoassays, which is something that I've been talking about this for more than 20 years. I think that I've shown you that 784 PTH does not exist, but I was not the only one, so other authors also showed that. Oxidized PTH does not seem to exist, at least according to our own experiments and also with the study that they perform at the Mayo and the CDC. I think, and I do really hope that the standardization of PTH assays will occur, which will have an implications with nephrological targets. If there is a good standardization and no cross-reactivities, then we could really have true values for PTH assays. Maybe I tease you a little bit with the bone alkaline, this new bone alkaline isoform that I do really think, which is interesting and needs probably further investigation. And that TRAF5B is very robust from analytical and probably also clinical perspective, and could be used as a bone resorption marker in CKD patient. And with this small pictures from my city town here in Liège, I would like really to thank you for your kind attention.
Thank you very much, Etienne, for this very, very exciting talk, and surely very confusing, and I am sure will raise many, many questions from the audience, from the participants. And the talk is open for questions. And I have one question here from Sandro Mazzaferro. Etienne, there is still any doubt about the PTH resistance? Does it exist yet? Since all PTH assay overestimate the normal assays. Do you think PTH resistance in bone exists?
Well, of course, my experiments did not show if they exist or not, but I think that, but you are all experts in this, but I think they exist. What I showed, a different concentration, was more that if we re-standardize everything on the standard, and then maybe that we should reassess this kind of studies. But I think that it's been shown in the past that there was this, even with other assays, that there was this kind of resistance to PTH. What I really show here was that probably, and again, this is a very early findings that I showed, that these fragments that we have been talking about that could have an impact on this resistance could not really be present, or at least measured by these immunoassays. So yes, maybe I personally think, but you are more clinicians, but this PTH resistance is really something that still is present. But what we do really now, if I want to pave the road, what I do really want to have now is excellent reference ranges that are traceable to reference standard and traceable to autonomous spec, and then have the exploration then in CKD and hemodialysis patient, and because I think that we are at very early pathway. Even if we saw that the story was done with PTH, I think that we still have lots of work to do on this. Also have multi-ethnic reference ranges also, because there is also this problem of resistance or fragments, so that also could occur in different ethnicities, and this also needs to be confirmed by mass spec, and I think that this is, well, something that is totally fascinating and that needs further exploration.
Okay, please, for the panelists, I think Marc and Hanne have some question to you too. Huh?
Yeah, I can start off, but Hanne,
we will alternate with you and the participant. We have some question also from the room. Go ahead, Marc.
I would
Hanne, please, Hanne.
Yeah, I would just like to thank Etienne for this very clear presentation. I think you're going to make life for nephrologists much easier with the death of the oxidized PTH and standardization of PTH assays, and it really fits well with the clinical data that's out there. We haven't been able to show a clear benefit for the whole PTH assay compared to the intact PTH assay. I just wanted to chime in with a comment also on PTH resistance, that I think most of the clinical data out there is that a high PTH, high turnover, can cause PTH resistance in bone. But then we were so confused with the story about the long PTH fragment from rats, which may have this antagonistic effect on PTH, and might this actually cause low bone turnover. I think if we can put this aside, then we can move this forward with PTH resistance. Very exciting.
And also these findings that they observed on the culture of osteoblasts by those fragments that could, at least that what I understood, they can modulate the activity of PTH is interesting, even if very preliminary, and also that this can be really also interesting and also needs to be further explored. Yeah, this is really interesting. But of course, I think that this oxidized PTH, well, no, I think that we had two different groups have shown that there was no presence. At least this is not a calculation. You see it or you don't see it, which is really the strength of this of the approach by mass spec, which does not give you an instrument that gives you a value, but gives you really a peak or not a peak. And here we did not see any peak, so that two different teams. So I think that this story should be over.
Okay, we take a question from Marc, please.
Yes.
Can I? Sorry.
We take one question from you, Marc,
Okay.
and then another.
Well, first of all,
I'd
like to echo what Hanne said. This was really enlightening to me. Thank you so much, Etienne. I'd like to challenge you a bit, and I agree that I'm happy to hear that oxidized PTH is now dead and buried. But my question is, if I look at your graph in which you compare your LCMS with the immunoassays for PTH, one could also state that frank hyperparathyroidism is hardly prevalent at all. Because also in stage 4 and stage 5, the numbers that have substantially increased PTH if measured by LC-MS is not so high at all.
It's very low.
Yeah.
Yeah.
So here you are referring to the slide that has been proposed by the Mayer, right? Not on my own slides. I agree, but I think that the high resolution mass spectrometry is not it's not the best, at least those that we have in our hands for the moment. It's not the best instrument to have the best accuracy for the quantification of PTH. So I think that here the triple quad that we use will give better. I'm sorry to be a bit technical, but what what will be difficult for nephrologists, is that you will have to see another scale of PTH. So if the reference range is should be around 30, 32, or up to 40 at most, this is at least twice of what you are used to have. And so if this is also amplified by if there is a 1.5 or 1.6 or even 2 with the Abbott on Siemens, for the Siemens assay or Abbott assay for 1 picogram of PTH, it will give you 2 picograms of PTH. So for such a patient that's got a value at 300 will have a value at 600. So the scale will be lower, and that will be probably one of the difficulties to consider that a frank hyperparathyroidism will be now with at lower PTH values to what we had in the past. And this is something that we need to, because of this standardization. So this is the benefit, and of course the difficulty of the standardization process. So that we change the value that we have. But for those who are used to work with third generation PTH assays, here, just like we do here in Liège, it will be not so much complicated, because this is more or less already the same value that we observe. Yeah. So what the PTH at 300 mean?
If I understand, Etienne, if I understand, you are saying that mass spec is overestimating probably the circulated concentration of PTH.
No. That's what I mean. I mean that if you re-standardize on the exact, if you quantify the exact concentration of 1-to-84 PTH, it's much lower than what you had in the past with the immunoassays. Okay. So if you re-standardize, for instance,
it is not it is not the gold standard. It's not good to measure the circulated concentration. It's not the method. Yeah.
It is the good standard. It is the gold standard. Well, time spec is the gold standard to quantify exactly the concentration of 1-to-84 PTH in the sample. Now, maybe that you've seen that when I presented you the graph, you see that some points are still not really completely in the scatter. So it means that these immunoassays cross-react with something which is not oxidized PTH, as we know, which is probably not the fragments, maybe other post-translational modified forms that we can identify with HRMS as they did in the Mayo. So there is still also things but to pick up some patients would have an unexplained high concentration. This will be worse to see if there were not other things. So that opens also a new era in such approach.
I have a comment from Jordi Bover. Donc, a fragment of PTH may not be the cause of PTH resistance in bone, but PTH, this data do not demonstrate that PTH resistance does not exist. This is one comment. And the other question here from the participants, Enrico Favaro, asked, among all biomarkers of MBD, in what and how do BLP, bone stability alkaline phosphatase, tell us something of new or predictive for the bone? Thank you.
I'm not sure to get to the question. So what does bone alkaline phosphatase add, the new isoform, you mean, or the total activity?
No, the bone specific alkaline phosphatase provided something new about all these biomarkers.
I guess Enrico is referring to what it will clinically mean. Well,
bone alkaline phosphatase is really a bone formation marker, and we already showed in the past that there was, that this really reflects what's going on in the bone, and we know that it can take some time to see the effect on the bone in patients, and bone alkaline phosphatase is moving slowly there was a nice graph that I think that the paper that we shared together, you got the PTH is going up and down quite fast, but the bone alkaline phosphatase is giving you the global trend of what's going on in the bone formation or turnover, bone turnover in the patients. So I think that it's really important that we do not see just a cut value, but how the patient changes over time, and bone alkaline phosphatase for that is a good marker for me for such an approach. But maybe Hanne want to say something on this.
Yeah, I can chime in. I always want to make the distinction between the markers that are affecting the bone and the markers that are reflecting the bone. So I mean, we talk about both PTH and bone turnover markers today. So PTH is affecting the bone. It's sort of it's the root of all evil. If you're an osteoporosis person, yeah, it's causing demineralization of the bone. But it's also competing with a lot of other factors. For example, glucocorticoids, which will depress bone turnover. So in the face of glucocorticoids, or for example, bisphosphonate treatment, your PTH will not reflect what's going on in the bone, while the bone turnover markers are passively secreted from the bone. So there should be a better reflection of what is happening right now. So for example, in the clinical setting, if you want to monitor a therapeutic response, then the bone-specific alkaline phosphatase should be better at that than, for example, PTH, because it should reflect what's happening right now after you've given your anti-resorptive, for example.
Thank you. That was one of the comments from Enrico. Can we also continue really to consider PTH as a marker of bone remodeling activity? You answered his question, Hanne. PTH is an effector, is affecting the bone and not, reflecting the bone.
A bone marker.
Yeah.
Maybe Hanne, you can comment on the ratio of PTH over bone alkaline phosphatase. It's a measure of bone responsiveness to PTH.
Well, this could be a very long subject. I mean, but I'm a bit skeptical to this concept of PTH resistance in CKD, particularly one that should be causing low bone turnover. I think what we mainly see from clinical data is then we have severe hyperparathyroidism, then this ratio of bone turnover markers to PTH goes down. And this makes sense from biological perspective, that the bone would sort of be protecting itself, that you have this desensitization. But yeah, you could potentially use the ratio of bone turnover marker to PTH to see what response are you skeleton per unit of PTH. It's also a bit tricky, yeah, because it can't be a linear relationship. You can't expect a PTH increase from 10 to 20 to mean the same as a PTH increase from 210 to 220. I mean, I'm not sure if this is answering your question, Marc.
Yes. Etienne, I have one question for you. If I'm right, there are 3 fragments. I mean, the 2884, 3884, 4584 that block the effect of intact PTH on the PTH receptor. And the other fragment, the 4584, is like the 5384 that was shown by More years ago that stimulate alkaline phosphatase on osteoblast and culture. Can you comment about that? I mean,
well, it's difficult because these are these early findings that have been shown by the Mayo and the CDC on this. So I'm really wondering if this is really something that we see in vitro, or if there is also an explanation of that in vivo. And this is always the problem of the translation of basic science into clinical aspects. And why would those fragments modulate the activity of the 124? I don't know. I'm really unsure of this. And you're right. So when I saw this paper, and I was a bit okay. Well, I was very happy to see this, but on the other hand, say okay. And also when you see that this 1-84 that starts only at the last stage is also a bit well, I don't know, Pablo. I think that we are at very early path of this thing, and that we should really have other studies and also
I think
exchanging
this is only the beginning. Another
exactly
history.
And exchanging between labs that are able to measure these fragments on the PTH and also of course confirm our findings. You know, this this is very important, that not somebody alone finds something that it can be reproduced by others, and that's important, I believe.
I think you have we have still time for 2 or 3 questions. Jordi asked, will B1X clinically available?
Well, if you need to ask that to Matthias and Per. So yeah, they proposed. Well, I don't know if they propose it in routine, but at least they've been publishing very nice and interesting papers. And I think that I know 5 or 6 papers that are really going always in the same direction, showing the interest of this B1X. And of course, what is complicated with this approach, with this catalytic measure of the separation on the colon, and then measure of the activity of the isoforms that go out of the column, and maybe now with the different approach that we can have with against separation and quantification, that we could broaden this approach. But I would love to do it, and to at least to work on that also. But I think that it's more also finding that is still in the labs for the moment, and not still in the clinics, at least. But maybe Matthias would disagree with me.
Hanne, Marco, any other questions?
Well, maybe I can ask Marc, do you use bone turn markers in clinical practice?
Are you asking me?
Yes.
Well, we can measure TRP5B, which to me seems to be an ideal biomarker in patients on hemo only for research now, but I would love to have it clinically available.
We do, Hanne. We measure PTH and bone-specific alkaline phosphatase every 6 months in all hemodialysis patients here in Paris.
Yeah, I was thinking more, are you separating it? So are you looking at bone turnover markers specifically and then putting PTH to the side?
No, we are combining them both. Mm-hmm. And I have a question for Etienne. There is a threshold for total alkaline phosphatase and bone-specific alkaline phosphatase because there is a cross-reactivity. And when you have a patient with liver disease and a certain amount of total, the bone is less specific.
Yes, you're right. So there is 15% cross-reactivity of a lack of specificity of the bone alkaline phosphatase, but still in those patients having very important liver disease, you can have an increase of the bone alkaline phosphatase also, which is of course a lack of specificity, but it's known, and I agree. But still, it's more specific than the total amount of alkaline phosphatase, at least because you don't know for its total amount whether it comes from the liver or the bone. But I agree with you that there is a 15% cross-reactivity, and it's not so specific. So we prefer to say bone alkaline phosphatase because this.
Okay, thank you, Etienne. We are running out of time. It has been a very, very exciting talk, a very great seminar. I want to thank all the participants. I want to thank all the panelists, and I hope I see you soon with the news about that.
Have a good night. Thank you very much. Thank you very much, Pablo. Thank you, Hanne. Thank you, Marc. Bye-bye.